absorb air or the ability to absorb water. And in flotation, densities of solids does not affect the separation process. So for the classifications of flotation, the first classification is the ore flotation, which is composed of two parts. The tailings, which are the solids that sink, are usually the undesired material, and the concentrate, or the solids that float or being floated, are usually the desired material. Number 2 is the macroflotation, which is the removal of macroscopic particles. And number 3 is the microflotation, which is the removal of microscopic particles, particularly colloids or microorganisms. Next is precipitate flotation, wherein a precipitate is removed by a collector. And number 5 is the ion flotation, which is the removal of surface inactive ions by a collector, thus yielding an insoluble product. Next is the molecular flotation, which is the removal of surface inactive molecules through the use of collector, yielding an insoluble product. And the absorbing colloid flotation, which is the removal of dissolved materials in piggyback fashion by absorption or colloidal particles. For a flotation unit or cell, its components are the tank or vessel, wherein this is the part where the feed is added, the overflow for froth removal, the discharge for tailings, and the provision for introduction of air for froth formation and agitation.
So I'm Denver, and I'm discussing the flotation unit or cell. So we're here to discuss flow diagram of a flotation process. From the feed goes to the mill, then to classifier, to conditioner, then to rougher, then to cleaner, to get the final concentrate. I will discuss the parts of the flotation process. For mill, usually ball or a crusher. Particles larger than 20 are crushed to desired particle size. Size range for suitable flotation process is from 200 mesh to 20. Vibrating swings or classifiers. Particle sizes are controlled priorly. Then next to conditioner, this is a part of from classifier to conditioner, then to rougher, then to scavenger. Desired material is further removed from the undesired material or tailings. Then cleaner, the concentrate is further freed from the tailings. Let's now call on G to discuss about flotation reagents.
So I'm going to discuss about flotation reagents. So flotation reagents, it allows separation of the desired solid from the undesired ones by making desired materials attached to the air bubbles. There are different types of flotation reagents. These are the collectors, the frothers, and the modifiers. The first one is the collectors. Collectors are surface active reagents that are added to the flotation pump where they absorb selective on the surface of the particles and render them hydrophobic as ferritin films. There are different types of collectors. These are the non-ionizing collectors and the ionizing collectors. Non-ionizing collectors are usually insoluble in water and cause the particles to become hydrophobic by converting them with the thin film. Examples are fuel oils and kerosenes. Dosages requirements are from 0.1 to 1 gram of reagent per kilogram of solids. The other one is the ionizing collectors, which dissociate in ions in water and are made up of complex heteropolar molecules. They can be classified as ionic or anionic depending the non-ionizing and the ionizing. The ionizing is can be classified as anionic or cationic. Then the anionic can be classified into two groups, the oxyhydryl and the sulfhydryl. Then these are the examples: carboxylic sulfates, sulfonates, sandates, and diphlophosphates for the anionic collectors. So next is the frothers. Frothers are surface active reagents added to the flotation pulp primarily to stabilize the air bubbles for effective particle bubble attachment, carryover of particle-laden bubbles to the froth, and removal of the froth. It is actually similar to the ionizing collectors except that they concentrate primarily at the air-liquid interface. Examples of frothers are pine oil, precilic acid, polypropylene glycol, short chain alcohols, and 5 to 8 carbon aliphatic alcohols. The third one is the modifiers. And modifiers are modifiers have different types. These are the activators, pH regulators, depressants, and dispersants and flocculants. First is the activators. Activators are used to make a mineral surface amenable to collector cooling. However, pH regulators are regulators such as lime, caustic soda, soda ash, and sulfuric acid. They are used to control or adjust pH. Then the depressants. Depressants assist in selectivity. Selectivity, the shortness of the separation. And then the last one is the dispersants and flocculants. It is important for the control of slimes that sometimes interfere with the selectivity and increase reagent consumption. For the equipment, here is N.
Now let's discuss the equipment on the flotation. So in flotation, there are three kinds of flotation equipment: electrolytic, dissolved air, and dispersed air. Let's discuss first the electrolytic flotation equipment. Electrolytic flotation units, also known as electroflotation. It is based on the generation of hydrogen and oxygen bubbles in a dilute solution, aqueous solution, by passing direct current between two electrodes. Electrode materials were aluminum, platinized titanium coated with lead dioxide, and stainless steel of varying grades. Electrical power is on the range of 5 to 10 volts. Power consumption is from 0.5 to 0.7 kilowatts per square meter of flotation tank. Surface area depending on the conductivity of the liquid and the distance between the electrodes. This is a diagram of the electrolytic flotation. Next, let's go to dissolved air flotation units. It entails saturating the process streams with air and generating air bubbles by releasing the pressure. Particle bubble contact is achieved by the direct accumulation and growth of air bubbles on the particles, and very little mechanical agitation is employed. Dissolved air precipitates in the form of fine bubbles in the size range of 20 to 100 mm. It does not require the addition of further time with chemical reagents and often limits the total quantity of aeration possible. It also treats process streams with low solid concentrations from 0.01 to 2% by volume. It has two main types. Vacuum flotation process stream is saturated with air at atmospheric pressure and vacuum supplied, giving rise to the generation of the air bubbles. It is a batch process, and the amount of air released is limited by the vacuum achievable. Next is the pressure flotation, which is the most widely used. Pressurizing and aerating the process stream and introducing it into the flotation vessel that is maintained at atmospheric pressure. And it is a continuous process This is a schematic diagram of the dissolved air flotation pan. Then let's go to the last slide, which is the dispersed air flotation cell. Pneumatic cells depends upon compressed air from mild agitation. Produces a clean froth but needs 50% more contact time and pump must be fully conditioned before flotation. Examples are hollow cell, which contains horizontal blankets, needs special care when cleaning the blankets to prevent tearing of cloth, used for solids that are easily floated without weight agitation. Hollow Macintosh cell. Air passed through by means of a perforated rotor made from steel tube and covered with either perforated rubber or cloth. The cloth does not glide easily due to the rotation of the tube. Pneumatic cells, which is the second type of dispersed air flotation cell. Depends upon compressed air for mild agitation, produces a clean froth but needs 50% more contact time and pump must be fully conditioned before flotation. Flotation column. Flotation columns belong to the class of pneumatic devices in the air bubble generation is accomplished by a gas parting system and no mechanical agitation is employed. Columns are built of long tubes of either circular or square cross sections that are commonly fitted with internal vacuum. They are usually 10 or even 15 meters high with a cross-sectional area of 5 to 10 square meters. This is a schematic of a flotation column, which is in pairing. Mount column. It represents a minor variation to the basic column design in that it provides for corrugated plate type mount. The packing feature enables uniform bubble size throughout the height, intimate particle bubble contact, increase residence time of the slurry and bubble phases in the column in a deeper froth zone. This is a pack column. Jameson cell, a combination column cell design. It includes a vertical downcomer column in which the air and pulp are dispersed into a dense foam of fine bubbles, creating a favorable environment for particle bubble contact. The bubble mixture is then discharged into a cell which allows a separation of particle-laden bubbles for the pulp.
So for the air sprayed hydrocyclone, it's a distinctly different design consisting of two concentric tubes with a conventional cyclone header at the top, providing for a tangential entry of the tube. As the tube slurry swirls down the inner pores through which the air is forged, the collision between centrifuged particles and air bubbles takes place, leading to the recovery of hydrophobic particles. Then, the bubble hydrophobic particle aggregates are transported into the overflow stream as froth, while the non-floating particles are removed with the underflow. So, we'll be presenting a video showing an example of an air sprayed hydrocyclone.